Hello, and for this video we're going to look at how to convert recurring decimals to fractions. If you're not sure about how to convert normal decimals to fractions, then go and give my other video on that topic a look first. So first of all, recurring decimals essentially means repeating and continuing over and over. For example, 0.4 recurring is just 0.4444444 and so on, right? It's just going to be that on and on forever. Speaking of recurring, this dot I drew up here, that's the symbol for recurring. You might also see the other symbol for recurring, which is this bar at the top. They just mean the same thing. It tends to be, I believe, that the bar is more of an American thing, and the point is probably everywhere else. So yeah, that is what a recurring decimal is. Recurring means repeating on and on forever. So now, when it comes to converting these recurring decimals to fractions, we need to think similarly to how we convert normal decimals to fractions. So let's say we have 0.3 recurring. So again, this just means 0.333, and so on. Like, it's going to be that on forever, right? So normally, to convert decimal to a fraction, we'd times it by 10 or 100. In this case, well, that's the problem. So if we do if it was 0.3, we'd times that by 10 to get 0, to get 3, and 3 over 10, that's the fraction, right? But because it's recurring, if we do 0.3 times 10, we get 3.3, and it's still recurring there, right? It's still going 3, 3, 3, 3, 3, 3. So that's the issue. Therein the issue lies. If we times by 100, it will be 33.3 recurring. Again, it doesn't really help us. So we want to make it a nice round whole integer. And one way we could do that, if we take this 3.3, so 0.3 times 10, as I just said, 3.3 recurring. Now to make it a whole integer, what we could do is just take away 0.3 recurring. Because, infinity minus infinity, that's just going to be 0, right? So 3.3 recurring, take away 0.3 recurring, it's just going to be left with 3, right? Because this 3 minus 3 should be 0. 3 minus 3, minus 3 minus 0, sorry, 3. So we left with a nice round integer. So that's the first step. And we've done the hard part, basically. We've got the integer. So now we need to take this back a little bit and throw some algebra in there. So let's start again, 0.3 recurring. And let's say x is equal to 0.3 recurring. So if we then say, so before we did 0.3 times 10, so we're going to times this by 10, so 10x, because we're timing them by 10, it's 3.3 recurring. And then what we did before is we took them away. So we're saying 10x, take away x, 3.3 take away minus 0.3. So again, same thing here, 3.3 recurring, take away 0.3 recurring. 10x take away x, 9x. And as we did before, that's just going to be 3, right? 3.3 recurring, take away 0.3 recurring, just left with 3. Then we're almost there, so again we will make x the subject, and that gives us the fraction. So divide both sides by 9, x is 3 over 9. And we can simplify this to 1 over 3, as 3 goes into 3 once, and 3 goes into 9 3 times. And we are left with our final answer, our simplest fraction, converting 0.3 recurring into 1 over 3. And now I'm sure many of you would already have known this even when we started looking at 0.3 recurring, that it is a third. But that is the whole process of how we actually get there, diluted down to a few steps. So it involves a bit of algebra and then rearranging it slightly. Nothing too crazy. Okay, so let's have a look at another example. Let's take, so x is equal to 0.4 recurring. So that's our recurring decimal. Again, just to hammer it in, that just means 0.444, going on forever. And we want to make this a fraction. So, similar process to last time. I want to times this by 10. So, 10x's. So, x times 10, this time 0.4 recurring times 10 is 4.4 recurring. Then we want to take it away because we want to get rid of this recurring here, right? We want to make it a nice round whole integer. In this case, probably going to be 4, isn't it? So, 4.4 recurring, take away 0.4 recurring. Just going to be left with 4, aren't we? 4.4. 4 recurring, take away 0.4 recurring is 0. 4 take away 0 is 4. So we're left with 4. So, 10x, take away x, it's 9x. And these are the same things, right? Because we know 10x is 4.4 recurring, 0.4 is equal to x, so 9x equals 4. And again, just rearrange it slightly. So x, sorry it's bad, x, divide both sides by 9, x is 4 over 9. Can we simplify it any further? No, we can't. So that is our final answer. 4.4 recurring, sorry, 0.4 recurring, oops, is 4 over 9. Okay, hopefully that was all making a little bit of sense. So, let's have a look at one last example, slightly harder. Let's say we have a recurring decimal 0.12, where they're both recurring. So the way the recurring decimal point works for decimals, if they're above it, if the point is above the number, that means those numbers are recurring. So in case this one is going to be like 1, 2, 1, 2, 1, 2, 1, 2, and on forever, right? It's not going to look like 0.22222 or anything like that. We'll look in another video maybe at harder recurring decimals, but we'll keep this will be the hardest one for this video. So 1, 2, 1, 2, 1, 2. So again, it's going to be a similar thing, where in the previous video, we can't times this by 10, because if we times this by 10, we'd get 1.2, but then it's recurring, isn't it? So it'd be 1, 2, 1, 2, 1, 2. And we can't, if we took 0.12 away from this, well, we'd get something weird, wouldn't we? We'd get like 0.09 recurring or something like that, which isn't what we want. A nice round whole integer. So, write that out. So, that's not going to work. So we want to times it by 100. Similar to before, depending on the factor, we want to times it by 100 or 1000. So in this case, times it by 100, it's going to look like that. Yeah? So 12.121212. Now this is where we take it away to make it a nice round. What do we take away from this to make it a nice whole integer? The original factor. So 12.12 recurring, take away 0.12 recurring, 0, 0, and 12. So we have our nice whole integer of 12. And that was the same as 100x, because we're doing times 100. So 100x, take away x. Next, in this case, x was 0.12 recurring. That's equal to x. And that was equal to 100x, because we times it by 100. And that equals 12. So 99x equals 12. X equals 12 over 99. Divide both sides by 3. And then, same thing, we need to simplify this. So 3 goes into 12 4 times, and it goes into 99 33 times. So our final answer is that 0.12 recurring is equal to 4 over 33. Now, hopefully all these questions made a little bit of sense. And again, like with this last video, if you want to practice a little bit further, just make up some recurring decimals. Say, I want to know what 0.1 recurring is as a fraction. I want to know what 0.29 is as a recurring fraction. Yeah, so it's simple, and then just look it up. Say, what is 0.29 recurring online in Google as a simplified fraction, and it will give you hopefully the same answer that you worked out. Yeah, and that is all for this video. I will look at some harder questions of these in the next video. Yeah, thank you for watching. Cheers.